Hey guys, Mr. Gibson here. I'm going to show you guys how to calculate average rate of change. It says on an interval. An interval is just between two x values on a graph. Okay. So average rate of change is related to slope. Slope is the average rate of change on a line, but that's constant. That's always the same average rate of change. So it's called a slope. As you go through high school math, you'll have other figures, other curves that aren't just lines. So they won't have a constant rate of change like a line. You'll have to calculate an average rate of change. So that's why we're going to call it average rate of change. Okay, so the average rate of change is the change in y over the change in x. Okay, that's all this equation means. So what it means here is I have 2 points, x1, y1, x2, y2. And what I'm going to do is the change in y is y2 minus y1. Change in x is x2 minus x1. Okay. This looks different in tables and graphs. In a graph, here's a crazy curve here that you'll start to see here in high school. Okay. And the average rate of change, look, I drew a line right there, like a slope, between these 2 points. This line right here is called the average rate of change. Okay? It actually has a special name called a secant line, but you'll learn that later on. Okay? But as you guys can see, it's not a constant rate of change throughout the entire curve, but between those 2 points, that's the average rate of change. In a table, you can find it pretty quickly. You just find the differences in the x and the differences in the y's, okay? Related to this idea of a first difference, okay? You'll see some examples of that later on. For equations, again, we're using function notation here. Plug in x values into the equations to find y values, okay? So the plugging in x sub 1 into the function f will give you y sub 1. Plugging in x sub 2 into the function f will give you y sub 2. Okay? So here's a couple of examples. Here's a graphic example. I have 2 points. Here's my interval. From x is negative 2 to 5. So right here, negative 2, 3 is my first point. 5, 2 is my second point. Okay? Here's our average rate of change. y2 is 2. y1 is 3. So that's where I get 2 minus 3. There's a difference right there. Okay? x2 is 5. Minus y1 is negative 2. 5 minus negative 2 is positive 7. The average rate of change is 1/7 in this case. Here's a table example. Again, interval 0 to 3. So that's where x is 0 to where x is 3. So I look at my table, x is 0, x is 3. I'm going to do my difference. x2 minus x1, so that's 3 minus 0. That's 3. Goes on the bottom because that's the change in x. So look at the values of y where x is 0, x is 3. Where x is 3, the y value is 28, so we have 28 minus y1, which is where x is 0, y is 2. 28 minus 2 is 26. So you put the 26 over the 2, just leave it like that. Just leave it like that. Finally, here's an equation example. And this is a little more difficult. So we have our function here. F of x equals negative 3x plus 2. We want the interval negative 4 to 5. Okay? So I want to find y sub 1. So that's where y, what is y? What is the output when x is negative 4? So we plug in negative 4. Negative 3 times negative 4, that's 12 plus 2 is 14. Negative 4, 14. y2, so I want the value when the x value and the second x value, so when x is 5. F of 5 equals negative 3 times 5 plus 2. Okay, negative 3 times 5 is negative 15 plus 2. Okay, negative 15 plus 2 is negative 13. So there's my value, my y value right here. negative 13. So now I've got my 2 points. I have negative 4, 14, and 5, 3. Okay? So let's figure, or 5, negative 13. So let's plug it in here. Let me fix this. Okay? So let's calculate this average rate of change. So, change in y. That means I want negative 13, because that's my y sub 2, minus 14, because that's my y sub 1. My x sub 2 is 5, so I want 5 right here, minus my x sub 1, which is negative 4, okay? So my second x minus my first x is on the bottom, okay? Negative 13 minus 14 is negative 27, okay? 5 minus negative 4 is the same thing as 5 plus 4, so that's 9, okay? Negative 27 divided by 9 is negative 3. Okay. Thanks for your attention.